We've got some inequalities, equations, and simultaneous equations to solve here. Let's do this. Right, first up, we've got an inequality. You solve this just like an equation with x on both sides. You treat this a bit like an equals. So the first thing to do is get x on both sides by minusing x, and that's going to give me 4x plus 1 is greater than 13. I'm then going to minus 1 from both sides. So I'm left with 4x is greater than 12. And finally, divide through by 4, and that will leave me with x is greater than 3. I have to have the x is greater than in. I can't just write 3 because there's actually an infinite number of solutions, and I'm writing them all down with this inequality. Write down the largest integer that satisfies this. Okay, I think the first thing to do, if you've forgotten what integer is just to solve for x. So I'm going to do this more quickly now. I can add 1 to both sides. 5x is less than 11, and I can divide through by 5. X is going to be less than 11 over 5, which is 2.2. So what's the largest integer that satisfies this? X can be any value that's less than 2.2. And you know what? Let's get a little number line going. So I've got like 1, I've got 2, I've got 3. Okay, it actually turns out that I've got all the numbers going this way. And the largest integer is the largest whole number, and that's going to be 2. Okay, B, solve 3x squared equals 75. Right, it's got an x squared in there now. We can't sort of divide through by x or anything. The key thing is to get x squared by itself. So I'm going to divide through by 3. And that's going to leave me with x squared equals 25. And now I'm thinking of a number that I square. I multiply it by itself to give 25. What number is that? Well, 5 jumps to mind, and actually that is the square root of 25. But there is another one if I'm doing it fully, because there's plus and minus root 25. It's actually 2 answers, plus and minus 5. So you could write that as your answer, or you could write 5 or minus 5. Okay, sometimes you get away with not putting the negative answer in. I don't actually, I've not checked the mark scheme here. My teacher advice is when you have a quadratic, expect there to be 2 solutions, and don't forget about this minus 1. Okay, lastly, simultaneous equation. We've got 4x plus 3y equals 5, 2x plus 3y equals 1. Imagine these like sets of scales, like the top one's balanced, the bottom one's balanced. You can kind of combine them and it still be balanced. So what we're going to do is we're going to minus the left-hand sides and we're going to minus the right-hand sides. Why am I doing this? Because now these 3y's cancel and I'm left with 2x equals 4. Divide through by 2, x equals 2. Brilliant. That's going to be one of my solutions. I'm not quite done though. So now I need to substitute it back in. Let's substitute it back into the bottom one. No real reason for that, just because I've got a slightly smaller value of x. It's only 2x instead of 4x. So sub back in. It's going to be 2 times 2 plus 3y equals 1. That is 4 plus 3y equals 1, which gives 3y equals minus 3, and hence y is equal to minus 1. And that is my solution.